So far we have discussed about concave mirror and convex mirror, their ray diagrams and mirror formula. Mirror formula, that is 1 by f equals to 1 by v plus 1 by u. So that is a mirror formula that we have discussed up to now, right? So then while using the mirror formula, every time while we use mirror formula, we have to use some sign conventions. Either that we have the mirror formula that 1 by f equals to 1 by u plus 1 by v. So that is 1 by f equals to 1 by u plus 1 by v, or else 1 by v plus 1 by u. There is no difference. So for this we have to use the signs, positive sign or negative sign, or focal length should be taken positive or negative, object distance should be taken positive or negative, image distance should be taken positive or negative. So that should be known. Yes, so those signs, SIGNS signs, okay, those signs, for taking those signs we have some rules. We have some rules. Those are called as sign conventions for the mirror formula. First, while measuring all these distances, focal length, object distance and image distance, these three are nothing but the distances. Yes, what is focal length? The distance between pole and focus is called focal length. It is a distance. The distance between pole and center of curvature is called radius of curvature. Yes, so that is also a distance. And next, the distance between pole and object is object distance, that is also a distance. And the distance between a pole and image, if the image is formed between the image and the mirror, so that is also a distance. So all these distances, these are all distances. So all these distances should be measured from pole. All the distances should be measured from pole. So if let us take focal length. Yes, focal length should be measured from pole to focus, not from focus to pole. Is it right? Yes. So focal length should be measured from pole to focus, not from focus to pole. Object distance should be measured from pole to object, not from object to pole. Right? So every distance must be started measuring from pole. Yes, all the distances must be measured from pole. That is the first sign convention. Yes, next, second. Okay, so we are measuring the distance. All the distances should be measured from pole, and now we are going to measure the distance. Okay, let us take first distance, that is object distance. Let us measure object distance. Okay, so this is the object, it is placed here, B and center of curvature. Yes, so let us measure the object distance. So here, if you draw the ray diagram like this, the incident ray will be fallen. Yes, so like this the incident ray will be fallen and it will be the reflected ray, and if you take another ray, the ray 2, and it is the reflected ray, and here the image will be formed. The image is between F and C. This is I dash. Yes, so it is the ray diagram. In this we have to measure the focal length, object distance and image distance. Yes, all the distances should be measured from pole. Yes, let us measure the object distance now. Object distance, it is nothing but it is the distance between pole and object. Yes, so we are measuring from pole to object. So we are measuring in this direction. Yes, from my right side to left side I am measuring. Yes, that means from pole to object, in this direction I am measuring. This is the direction that I am measuring the object distance. Yes, here while taking the sign for that object distance, we have to consider the incident ray. Yes, in which direction the incident ray is present and in which direction we are measuring the distance. Okay, that is important here. Let us take the rule. In the direction of incident ray, the distance which is measured in the direction of incident ray should be taken positive. The distance which is measured in the direction opposite to the direction of incident ray, should be taken negative sign. Yes, so here this is the direction of incident ray. From there to here, it is the direction of incident ray. And how we are measuring here? From pole to object. Incident ray is from object to mirror. object to mirror, and we are measuring from mirror to object. So we are in opposite direction to the direction of incident ray, right? So we are measuring in the direction opposite to the direction of incident ray. So that is why it should be taken negative. Yes, if we are measuring in the direction along this direction, yes, so if the object is here, yes, at that time we should take a positive, but there is no chance for the object to be here, right? Yes, so here in this case object distance should be taken negative. Yes, for concave mirror object distance is negative. Yes, so while we are measuring focal length, let us measure the focal length. So the focal length is nothing but the distance between pole and focus from here to here. So as we are measuring from here to here, it is also opposite to the direction of incident ray. Opposite to the direction of incident ray we are measuring. So that is why it also should be taken negative. So focal length also negative for concave mirror. Yes, radius of curvature also should be negative for concave mirror. And next, image distance. Image distance also we measure from pole to image, from mirror to image. In this direction we measure, and the direction of incident ray is like this. Yes, that also negative. So for concave mirror, focal length is negative, object distance is negative, and image distance is negative in this case, except one case it is always negative for concave mirror. What is that case? When we place the object in between pole and focus, where the image will be formed inside the mirror. Image will be formed inside the mirror. In that case, image distance will be positive because we measure in the direction of incident ray. Is it clear? Yes. So for concave mirror, focal length always negative, object distance always negative. Yes, image distance negative, always negative, except one case, that is when the object is placed between pole and focus. Is it clear? Yes. And next, height of the image or object. Height of the image. Next sign convention, height of the image or height of the object. For height of the image, height of the object, which type of sign we have to take. Yes, so here let us take height of the image or object to be taken positive if we measure upwards from the principal axis, and it is to be taken negative if we measure downwards from the principal axis, right? So here height of the image or object, if we measure upwards from the principal axis, positive. If we measure downwards from the principal axis, negative. What is that? Let's see. Yes, height. Always we start, yes, if it is placed here, we don't start from O dash to O. Yes, we should start from principal axis to the height of the object. Yes, from downwards to upward we take here. That means from principal axis to upward if we measure, yes, so that should be taken positive. If we measure upwards from the principal axis, we should take positive. And if we measure downwards from principal axis, should be taken negative. Right? So in this case, object height of the object should be taken positive. Height of the image should be taken negative. Height of the image should be taken negative. Is it clear? Yes. So what are the sign conventions now? Okay, so there are 3 sign conventions. What are those? First one, all the distances must be measured from pole. Yes. And next, the second sign convention about object distance and image distance. Yes. So that if a distance which is measured in the direction of along the direction of incident ray, then that should be taken positive. And if the distance is measured in the direction opposite to the direction of incident ray, that should be taken negative. Yes. So this is second sign convention. Next, third convention is about height of the image or height of the object. Height of the image or object should be taken positive if we measure the height upwards from the principal axis, and it should be taken negative if we measure downwards from the principal axis. Is that clear? Right. Next, for concave mirror, just I said about the sign conventions, and for convex mirror, focal length always positive, because the convex mirror will be in this manner. right? Here the object will be placed O dash, and here the image will be formed, and here the image will be formed, here focal length and center of curvature. Yes, so here in this case, in this convex mirror, first focal length, it is positive because we are measuring in the direction of incident ray. Yes, it is positive, focal length is positive. And object distance, negative always. Object will be placed here. Yes, and the direction of incident ray is like this, and we measure in this manner. Yes, in the opposite direction to the incident ray we measure. So that is why object distance negative always. And radius of curvature positive always. Focal length positive always. And next, image distance always positive. Image always, it will be formed inside the mirror. So that is why image distance is positive always. Yes, let's see one more time. Focal length for concave mirror, focal length is always negative. Object distance is always negative. Image distance always negative except one case. What is that case? When the object is placed between pole and focus. Yes, next, for convex mirror, focal length always positive. Object distance always negative. And image distance always positive. Yes, that's it.